All right. Hearing me now, I think, right? Everybody got me now? Sorry. Thank you. Good morning, good afternoon. Let me start all over again. And thank you for you guys out there that can that do point it up for me that, hey, can't hear you, man. You're just talking to yourself. And that does happen. So thank you for joining us for Takeo Tuesday. Dave Holdorf here. John Barber and Jason Cox are actually on the other side of that wall right now. We're in Chicago. If you notice, I'm not in my home office. We're not in Rhode Island at the factory. I am hanging out in Chicago at the moment, as you can tell by the coffee mug over my shoulder there. Sharing somebody's office at the moment, taking over Takeo Tuesday. So again, greatly appreciate you all swinging in for May 13th, our residential training session on domestic hot water sizing and controlling. All right, and talking about domestic hot water recirc. I look at recirc as one of those things that is so underlooked and underappreciated. If you stop and think about how many homes out there have hot water recirc in them and how many of them need it, all right, it's a wide difference. We're looking at less than 3% of homes that have it. We have about 98% of the homes that need it. Okay. So I do appreciate everybody jumping in today. Before I get started, like I know everybody can hear me now, so that's a good thing. All right. I see, yes, everybody's saying yes, yes, yes. All right. Let me know where you're from. All right. I know a couple people logged in already, and they always like to know where everybody's calling from and making sure you can see and hear me well today. So that does make things easy. So if you find the question section, that's the way you're talking to me today. I am monitoring those questions. I will periodically stop myself when I see some questions coming in to make sure that I answer them. There is no question answer period. You have the question, you type it in immediately, whether it's the slide that we're on or it was 2 slides ago. And if you're really good, the next slide. All right. So yes, we got Justin from Philly and we got Bill from Greenwood. Thank you. David from Detroit. All right. Also David from Kansas. All right. Excellent. Excellent. Robbie from Spokane. All right. That is awesome that now I know that everything is working on my side here. So I do have a really, really big question for everybody out there. All right. When it comes to sizing a residential recirc pump, does sizing matter? Now, obviously, if you were to answer that question no, there'd be no reason for us to do this webinar right now. All right. But does it really matter? All right. And making sure that you got the right flow to your system. Could you over pump a system? All right. When it comes to domestic hot water recirc, what do you guys think out there? What if it was too big of a pump? If you just grabbed any pump off the shelf, would that be okay? All right. I'm just curious as to what are some of your answers are going to be out there. If it was just anything off the shelf, you drop it in there and call it a day. All right. So David's saying no, Robbie's saying it's got issues, right? Yes, you can have some issues with your systems out there. And I'm going to show you a couple of those issues next, all right, as we jump in here. So sizing sure does have a critical mass here, all right, when we start looking at what we need to do, all right? And what we find is a lot of projects, a lot of domestic hot water recirculation. The circular is way oversized, therefore creating a lot of velocity of the water. All right, and what you see here is a couple of examples, all right, that we pulled offline. All right, you see the one on the right hand side, you see an elbow cut away from the inside. All right, and you're seeing the inside of the pipe, and it's eroded, it's corrosion. You'll see some pinholes that are going through here. And some people might look at this and say, well, that's normal. That's what copper does. All right, and it shouldn't. All right. You should not be eroding the pipe from the inside out. Oh yeah, well, it happens and you just got to make that fix. And next thing you know, you're going back every year for other pinholes that might be occurring out there in the copper pipe. So we want to find, so instead of just doing the repair, we want to find out why it's happening. It's not a normal thing. It should not happen at all. Okay. And it's not just limited to copper. All right. We might, for those of you out there that like to use your PEX tubing out there, say, hey, man, go PEX. It's impervious. All right. And it is not. All right. It is not to velocity. Velocity, high velocity of hot chlorinated water is going to kill any pipe material that you see out there. So we can have issues also on the PEX world as well when we're running very high velocities going out to our system. It can hurt things up. So what you see here on the right hand side, you can see the pipe split from the inside. All right, you see it also after the fact. On the left-hand side, you're seeing a barrier having an issue. Okay, so these are issues that are out there, and it's not just PEX and copper. All right, any type of pipe that you're going to see out there. So it really comes down to defining what recirc is. And I hate reading from a slide. I hate slides that have a bunch of words, but I really felt that this was the most important thing, because when it comes to sizing recirc systems, there's a lot of projects out there. You don't need to size it, just slap it in and just make sure the water gets moving. So here's my definition. Here's the definition for recirc. Is a hot water system, hot water recirculation system is a plumbing system that replaces hot water to the fixtures without draining and wasting the water. Without it, recirculating systems mechanically moves temperature from a water heater to the fixture. We're not looking at gallons per minute. We're not looking at a very high flow rate here. We just need to move temperature through our system. So I felt this was such a powerful definition that I need to make sure I shared it with everybody out there. So keep that in mind when it comes to sizing circulators and what its goal. What is our goal when it comes to sizing a recirc pump? All right, what do we need it to do? Is it to deliver hot water to the fixture? All right, and based upon my definition, it's a definite no. We are not using it to deliver hot water to the fixtures. Think about this for a second. If we didn't have a recirc pump installed, do you get hot water to your fixtures? That's the interesting question to answer. If you don't have a pump in the system, do you get hot water out there? So, and the answer to that is no, obviously. So therefore, do I need a pump to get the water there? All right. So all we're looking to do is take the water that was in the hot pipe that had cooled down and move it around back to the water heater to get heated back up again. So we just want to make sure that we keep the water lines primed. Okay. Now, a question came in. So for high rise, you need a booster pump. That's a different animal. All right. You can still add a recirculation system to a system that has a booster pump, but the booster is designed to get the water up to the highest points of the structure. A recirc pump is not designed to get the water up there. It's already there. All we want to do is prime the line. We want to take the cold water that's in that pipe, bring it back to the water heater to reheat it and fill that line up again in order to wait for somebody to use it. All right, because we're going to lose heat in the water. All right, hot goes to cold. All right, there's no way that we're going to be able to keep all of the hot water in the pipe. Insulation helps tremendously. Yes, it does. All right, but it doesn't stop it from happening. So yes, insulate all your lines, hot water, cold lines as well, if you want to make sure that you're not wasting that heat, that energy that you put into the water already. However, like we said, we got to watch the velocities of the water that we're flowing through. So we want to make sure that we're not choosing any old pump out to the system itself and therefore creating too high of a velocity moving that water around. So what is causing those pinhole leaks? All right, in copper, PEX, PVC pipe, it's all happening on every system out there. Okay, well, one, we start to end up seeing higher temperatures. All right, so over 140 degrees or so, we're going to see some pinhole leaks that can occur. All right, so that's part one. Part two, the velocity over 2 to 3 feet per second. All right, doesn't mean it has to be a target. All right, it's a maximum, all right, of the velocity of the water, not the gallons per minute. It's the speed that the water is running through those pipes. All right, and then of course having chlorinated water is going to do it. So hot chlorinated water moving at a high velocity is creating those pinhole leaks from the inside out on your systems. All right, so that's what we really need to pay attention to, all right, as we start moving it through. And then of course, how we control it. All right, so the first three is looking at the design of the system itself, but then how you control that circulator is important. All right, non-stop continuous circulation is not good to have that continuous high velocity hot chlorinated water. So those are the things that are causing those pinhole leaks in our systems. Now, This pinhole may not show up in the first year, maybe not the second year. All right. It depends on how bad it's going to be based upon how fast it's going to react. So it could be a decade, it could be something less, but it shouldn't happen at all. All right. And once it happens, it usually shows up at elbows. All right. Within 6 inches of that elbow, just because of the way the pipe is attached, and you've got an overlap. All right. And you end up with those little eddy currents, and you got the chlorides and anything else that's in the water that starts to erode the pipe from the inside out that way. So here's some information that we have found in the Copper Tube Handbook. And the Copper Tube Handbook is put together by the Copper Development Association. You can take a look at their website. You can download this book. And they talk about, in order for long life of the pipe itself, what are its limitations? And sometimes we look it over and we gloss over a couple of things that we may not apply to recirc. So the first thing that you see here, all right, is when we see water temperatures over 140 degrees, lower flow velocities like between 2 to 3 feet per second should not be exceeded. Now, right above it, you'll also see 8 feet per second for cold water and 5 feet per second for hot water. All right. When we start going over that 140, we want to drop that velocity down. Now, when we look at heating systems and closed loop hydronics, all right, 4 feet per second is normal. All right, but it's not continuous. All right, it spurts on a heating call. The other thing that we have to think about is that, yes, this is a plumbing system, so the water is not aggressive, but all water is aggressive. Water is the universal solvent. You give it enough time, it will break everything down. All right, so, but of course, as your water conditions wherever you are in the country change and are different, that could also affect it as well. All right, so again, hard water, soft water, all of these things could easily change it, and make sure you want to keep those velocities down lower. So due to constant circulation and elevated water temperature, attention needs to be paid to the velocities. This is all coming out of the Copper Tube Handbook. This is the book that's written by a bunch of engineers that all they do is know copper pipe inside and out, literally. All right. So we want to make sure that we're not exceeding it. So these are all excerpts taken right out of that on page 15, right in the beginning of the book, making sure that the circ pump is not oversized. All right. So very important. And sometimes it might do you better on your recirc line to oversize it to keep the velocity down. All right. So if you have the opportunity to design a plumbing system residentially and installing it new, bigger pipe is better. All right. Bigger pipe is better. Now, unfortunately, bigger pipe is worse for heat loss purposes. That's where insulation comes into play. But then for recirc world, bigger pipe would be better. So this is a chart that we have put together, all right, and it's not in the handouts here on the class. Unfortunately, since I've been traveling, I didn't get to log in and upload them, but these are also on our website. When you go to Taco Comfort, when you go to the Taco page, go to the training section, go to Taco After Dark, all right, and I'm sorry, Taco Tuesday, but when you see the online training, click on the word online training, it brings you to the page where we have all of our handouts for everything, and you'll find these charts there, okay? And what this is showing you right now, this is just a portion of it, showing you the type of pipe that you're using, the size of pipe, and then based upon the recirc gallons per minute and feet per second, you'll find what your GPM needs to be, okay? So you'll see here, whoops, sorry. All right, you'll see if you have 1/2 inch type M copper, all right, it is recommended to run at 2 feet per second, 1.6 gallons a minute maximum for the recirc portion. All right, now if you needed to push the limits, 3 feet, but they prefer 2. All right, you can get up to 2.4 gallons a minute on 1/2 inch. All right, you jump up to 3/4 inch, we can see 3.2 gallons a minute. Now, again, this is a maximum, not necessarily a target. All right, you may not ever need to go anywhere near 3 gallons a minute for a recirc system. So the lower the flow, the better it would be. So you pay attention to when we start working out a design, and I'll show you that in a little bit. All right, so here are the numbers coming from PEX. All right, so from the PEX manufacturers, all right, they talk about for your cold water piping. Now PEX, a little bit different, smaller ID on the inside, so the velocities automatically go up on the same flow rates. And they recommend 10 feet per second. all right? But that's in the cold water supply, not recirc, all right? So on the cold water supply, on the hot water side, they recommend maximum of 8 feet per second, all right? And I do know that there have been some changes from the PEX world out there about this 200 degrees that you see here, all right? So they do recommend lower temperatures in PEX tubing world. Now, this is our section, meaning the recirc, all right? They want to see a maximum of 2 feet per second. All right. Yes, you can do up to 8 on the hot water side of things, but now when you start doing recirc, they're down to 2. All right. And no more than 140 degrees. All right. No more than 140 degrees in the PEX world. So this is coming from the PEX manufacturers and PPI, the Plastic Pipe Institute. Does that help? Are there any questions out there? Again, everybody, make sure you type in some questions. I will take a look periodically to make sure there isn't. I see nothing at the moment. All right, so if you got any questions, again, you type them in as soon as you have it in your mind. The PEX chart, all right, was the next, whoops, darn it, I just messed everything up on my screen here. There we go. There we go, backwards. The chart is right there. All right, so there you go, Robbie. All right, so yes, we do have it. PEX is, all PEXs are rated in SDR 9, which is a standard dimensional ratio, all right, of 9. All right, and here are those recommended of 2 feet per second maximum. And here on a 1/2 inch line, we're looking at a maximum flow of 1.1 gallons a minute. All right, so again, lower flow. All right, David's asked 2 feet per second because it flows more often. No, because of smaller ID that you have on there. So they don't want to do that. You could push it to the 3. They want to keep it down to the 2. All right, so that's their recommendation so that we don't have failures in the pipe itself. Okay. Again, this chart is in those handouts that are on the website there. And if you have any troubles trying to get to them, shoot me an email. I'll make sure I give you the link. My email is dholdorf. You see my name underneath my picture at tacoinc.com. All right. And if you've ever been to a class with us here, as you guys know, we like to do the math. All right. It's not hard math. All right. We're going to be doing some estimates here as well. All right. But we have to do some math to figure out what flow do I need and find the heat loss of the pipe that's there. Okay. So we need to know an example. And these are approximate. So meaning, how is the house laid out? All right. And we typically have houses. It's not about how much pipe is installed in the house. We're looking at that main. So here's a system that we have as a T and branch or a trunk and main that you have here. All right. And the main is what we need to know. I don't need the branches coming off on going to your fixture groups. I need to know the main that's going down the center of the house, because then we always branch off to our fixture groups and ballpark this number. All right. You can see the pipe size coming off the water heater. And what I need to know is from the water heater all the way out to the furthest fixture, all right, and get each pipe and ballpark that. This number should be end either in a 5 or a 0, all right? If you start whipping out a tape measure, you're working too hard, all right? This needs to be a quick, easy exercise. So we take a look at it. We've got 1 inch pipe. We got 50 feet of 1 inch. Then we take a look at the 3/4 inch, and we got 40 plus 20 at 60. We got 70 feet at 3/4, and the last little bit of 1/2 inch at 10 feet. All right, so we need to know the supply lines to that furthest fixture, because that's what we're concerned with, is that furthest fixture. Then you need to know the return line. All right, those are 2 different animals, all right, that we need to know the return line and what size is being used there. All right, so how do we do that math? Well, we actually created a tool for you to do this. There are some worksheets that you can work through if you wanted to in the calculations and find the heat loss of the pipe based upon the pipe diameter that you have, the length of it in there. We're going through the heat load calculation. Then we apply the universal hydronics formula, calculated gallons per minute that we need to do. But we created a tool for you all. All right, and that tool is on our website that we call our DHW Recirc sizing app. All right, DHWR Size Right. All right, this link Now, again, this is just for a residential setting, not a commercial setting. This is residential. Okay. So I'm going to click on that, get my website to open up. All right. I want to make sure that everybody sees what I see. All right. All right. And you'll see here my sizing tools. We have our project builder for commercial applications. Here's our older project builder program. And here is the DHWR. So we're going to click on that. All right. And as we open that up, all right, you'll see here on the screen, there's a description telling you what this app does and what's going on with it, and a little bit of disclaimers that you have. All right. If you had several designs in there, just start over so you wipe everything out clean. So, but I know this is a clean start. First question is there an existing or will there be a recirc line installed? That's why we're here. All right, so I'm going to say yes. We're going to do a recirc line application here. There will be an instance when you need to choose no, okay? But that's a different design that we'll talk about at a different time. All right, now, what water heater type do you have? So we're going to click on it, and you have a couple of choices. You have tank style water heater. That could be fuel fired, electric, indirect tank. You could have your tankless, which is going to be a wall hung type application, or instantaneous, all right, on your tankless, or a coil in your boiler. All right, in your cast iron boilers, a lot of older designs do have that option to get your domestic hot water from a coil that's inserted in the boiler itself. For today's purposes, we're going to go with what the majority of people out there have, is that tank style design. And then you get to choose the supply pipe and the return pipe. So you might be adding recirc to a project, so you can go ahead and choose PEX. So we're going to leave it as a copper supply, and we're going to choose PEX as SDR9 as my return material. All right, so now you come down to simple enough, what size pipe and the length of pipe that you have in there. So you click the plus button to add that in there. So we click on the plus, and the first box shows up, and I'm going to start off with some 1-inch pipe. And wow, I already forgot what it was. I think it was around 60 feet of 1 inch. Then you go ahead and click on the next one, and we had some 3/4 inch for another 40 feet. I might be wrong on the numbers, but you guys get the idea. All right, I don't have them all memorized, and I do know the 1/2 inch was 10 feet. All right, and you drop that in there. Then you come down to the return line and says, all right, what do you have there? All right, and the dedicated return line, because, and I'll show you in a second why you need to break the two of them out. We had some 1/2 inch PEX, and we had 80 feet of that. And as soon as you hit out of this box, stuff comes alive and the calculations start. And so it said right here on the return, this line has a maximum flow limitation of 1.1 gallon a minute, because the 1/2 inch PEX is the smallest pipe in an entire system. That's my maximum flow. So when we jump down to the summary, you'll see that 1.1 gallons a minute has been dropped into this box here on my gallons flow. Now, the reason why we need to break the two of them out, meaning the supply line from the return line, let's click on the show details. And if I click on that, it gives you a little bit more information. My biggest concern is not about the water in the return pipe. We're concerned to make sure the supply pipe has hot water, that it's primed. If the return line has hot water in it, it doesn't matter to me because we're not using that in the house. So I want to make sure that my length of pipe on the supply, that's where my heat loss comes from. All right, and it shows me here we have 3.9 gallons of water in the supply pipe. So from the water heater all the way out to that furthest fixture, and if it was a lavatory, a bathroom sink, running, let's say, 1 gallon a minute, and if the water is cold in that entire line, how long does it take to get hot water? This one's an easy math question here that you should be able to do in your head. That fixture flows 1 gallon a minute. How long does it take to get hot water if you turn just that faucet on and all the water's cold in the supply pipe? And I know everybody does this at home, right? You're washing your hands in cold water at that furthest fixture. How long does it take to get hot water? Let's see here. Come on, somebody. Somebody's got to do the math in their head. It's easy. I'm giving it to you right there. There you go, David. 3.9 minutes, almost 4 minutes to get hot water. 4 minutes. That's how long it takes. The return line only has 0.74 gallons of water in it, so it's not a lot of water, all right, in the return line. But like I said, I'm concerned about that supply pipe, all right, and getting that water, all right, getting that warm water at the fixture itself, all right. Doesn't mean I need to pump 4 gallons a minute, all right. That's controls is different, all right. Controls is different here, all right. I need to keep my flow down to 1.1 gallon a minute here. Now, based upon the length of pipe here, it has calculated 3.74 total foot of head. And what it did was it also gave you a safety factor because we don't know the number of fittings. So copper pipe, every time there's an elbow in there, there's a pressure drop associated to it. Every fitting valve that we drop into it is going to have a pressure drop associated to it. So right now it has calculated that, the length of pipe that we have has about 2.3 foot of head based upon 1.1 gallon a minute. And it has an additional head loss of 1.4 to give us a safety factor at 3.74 foot ahead. So 1.1 at 3.7 foot of head gives me my flow in head in order to size my circulator. We come down a little bit further. You click on circ efficiencies, like what type of circulator do you want? You want the high efficiency ECM or standard efficiency. We're going to click on ECM. All right, and then we're going to leave connection type all for your application. Click on search, and it scrolls down, and it's showing you 2 different types of circulators or packages that we have. One being the 006E3, the second one being the Smart Plus E, which has a controller built in, all right, in the package. So let's just click on the first one here, and if I click on it, it pops up and it tells you a little bit of the specs on what the circulator is. All right, what is the maximum flow and head this circulator can do? What's the power draw of this thing? What sizes it comes in? All right, meaning the fittings that you put on here. The 006E3 is a union style connection, all right, with straight threads, so you get your connection that you have based upon the house. So we will probably go with a sweat connection. We could also go with threaded. We could also go with press fittings, all right, in order to install it in the system. But right next to the circulator, you'll see here, this is also clickable. And if you click on that, it's going to give you the pump curve, all right? And you can see here the maximum. If I left that dial turned all the way up, that's the maximum. The red dot here is my design. This is where I want to run the circulator. I don't want it to run any higher because that's going to give us the higher velocity in our system and start to erode the pipe out. Because everybody says, oh, well, it's got a dial on it. I'm going to turn it to max, and that's going to be better because the water's going to get there faster. All right. We don't need it to get there faster because if I turn it to max and if we put my system curve on here, it's going to operate way out here and deliver 3 gallons a minute going to this system. All right. Just about 3 and deliver about 13 foot ahead. All right. A lot of velocity is going to happen and start eroding that pipe from the inside out. All right, so I got a question. So by using this size, we decrease the wait time by 1 minute. What happens if we increase the size? If we increase the size, I can go higher flows. That's correct, but my limitation was that 1/2 inch. So yes, you are correct. If I increase it, and I'll show you that in a minute, that we can increase that. But what we also want to do is make sure that we control it properly so the water's already primed. You don't want to, so there are different ways to operate the circulator. We'll get to that towards the end of today's session. So right here, if I were to run this circulator on max running 3 gallons a minute, we're going to consume 44 watts of power. The beauty of the 006E3 is it has a dial on it, and wherever you turn the dial, that's the speed that it runs at. Minimum all the way down here is 4 watts of power. All right, low is giving us around 9-10 watts. So we're going to be sitting here right in between minimum and low and run about 6-7 watts of juice to run my recirc pump in my house. That's all I need to make sure that line stays primed. All right, flowing 1 gallon a minute through the pipe. All right, depending on how we control it is another story. All right, does that make sense? Does that make sense? Now, the other things that we can do, and if I come back to my design, let me close that out. Let's come back up to here, and I can turn around and let's say we did have a mixing valve in there. Now, mixing valve presents some more pressure drops to us. Now this one, our mixing valves that we have a seat. What we're looking for is the additional foot of head, all right, that this valve is going to do. So you'll have to look at some charts that you have, and this is going to add, say, an additional 1.8. All right, now let's see if I were to increase the flow here. If you see the white box, I can change the flow. And if I were to change this to 3 gallons a minute, all right, it's going to recalculate and says I've got 29 foot ahead. 29 foot ahead. We don't want to run 3 gallons a minute through this system. Or do I want to evacuate the water that fast? All right, we end up with 29 foot ahead in the system. If I come down and hit search, you're going to see that we're in big circulator world. All right, the 0034, which is 34 foot ahead, 50 gallons a minute is what this circulator can do. And if I click on the pump curve and see what it shows up on here, all right, and I happen to notice that didn't come up properly. Yep, there we go. Here is the pump curve. It ends up being way to the left of a curve. All right, way over here, because again, very low flow, but high head. All right, a lot of resistance, especially where the resistance came into play was going through that mix valve. All right, that mixing valve that we had there had a very high pressure drop to it. So when you work way over to the left, circulators want to see sweet spots. All right, you want to be somewhere in the middle, and this is way over to the left side again. So now it's not just a velocity issue that you're going to have. It could also be a long life of the circulator itself. Okay. So if I were to flow 1 gallon a minute through my system here, 1.1 gallon a minute, yes, I'm going to evacuate that water in about 4 minutes. All right, so again, it's a 4-minute evacuation time, but now controlling it's going to become the important part. All right, so let's see if I were to leave this one in here at 3 gallons a minute. Let's come up to here and get rid of that 1/2-inch pipe. All right, get rid of this 1/2-inch pipe, do my return pipe of 3/4 inch of 80 feet. Now it said I can do up to 2 gallons a minute, but if I were to change this to the same as that we had before at 3, all right, let me get rid of that mix valve in here. That mix valve is the one that's really throwing it off, but you can see that we dropped down to 13 foot ahead, and that's still leaving the mix valve inside. All right, so again, I don't like 3 gallons a minute going through a valve. The valve is adding 7 foot ahead to the system. It still gets us into a bigger circulator world. But the beauty is that this, again, we don't necessarily want this to be up there. So we probably want to see this more along the lines of 2 gallons a minute. All right, we leave the mix valve in there. And again, we're looking at small circulators. Again, this is something that we just need to prime the line, make sure it doesn't cool down, make sure it's available for when you want to use it. Okay, so yes, the question was, do we need to wait for it? Are we just only decreasing the wait time by 1 minute? No, the water's going to be hot when you're there. How you control the pump becomes the important part. Could we just use the minimum setting and just wait longer? You definitely could. You definitely could, yes. All right, so if you put it slower, it all depends on how you control it. So that's an excellent question there, David. So the lower the flow, the better it is for everybody around. But then again, it might be too long. All right. I mean, when we start looking 4 watts versus 7 watts, it's not that big of a savings that you would see. That's the difference in a nightlight, in running a nightlight in your house. So let's come back to the presentation. All right, making sure. So how do you control recirc? How do you control recirculation? And we can come back to the design in a little bit when we start talking about this. So how would you control? What's the easiest way to control a recirc pump? Just curious out there. What's the easiest way to control recirc? Timer? What's easier than a timer, Robbie? I mean, Gene. Yeah, Eugene. He said timer. Robbie said turn it on. That's right. Plug it in. All right. The easiest way is plug it in and make it run 24 hours, 7 days a week. All right. Yes, we see lots of those out there. You just put power to it and it runs continuously. All right. But as we know, we probably don't need it to do that. So let's do an aquastat, because if the water's warm in the pipe, all right, let's turn it off. It doesn't need to run any longer. So we throw an aquastat on there. So the aquastat, now the problem is that the aquastat always goes on the last leg of the return pipe. And like I said before, I don't care if it's warm on the return. So technically, your aquastat is supposed to go at the furthest fixture away. And that's usually the second floor of the house running wires back and forth. Yeah, we're not going to do that. We're just going to keep it in the boiler room. All right. And Eugene said, yes, go ahead and put a timer on it. All right. We have a couple of different timers that you can drop on. You know, these go on the standard 006. So we have the standard 24-hour timer that you see with the clock on it. And then we see the digital timer. All right. So on the digital timer, so the difference is one is 24-hour settings. The second one is digital, meaning I have several events a day I can make it turn on. So the one on the left, simple device. All right. Each pin that you see on here represents 15 minutes of runtime. And then you'll see hands of a clock on there. So you basically turn the clock to the time of the day, knock down the pins to when you think the pump is going to run. Now, here's the really, really interesting question, the $64,000 question. Who programs it? Who's going to do the programming? You, the installer, the homeowner? All right. So that's the interesting thing that we need to do. All right. And making sure you set it up properly. Now, the digital one on the right-hand side, that goes ahead and says, all right, well, now you can set up different events, let's say weekend and weekday. All right, because people use hot water differently on the weekends. It's most people in a home, it's a standard time of the day, a couple hours in the morning, couple hours in the evening. It all depends. All right. Eugene says you do the programming, but the homeowner can change it as well. That's right. However, the downside to this, the standard timer here that you see is it screws up a couple times a year. Daylight savings, power outage, and there is also a switch on here that goes from timer to on. Right now it's in the off position in the middle. All right, you flick it to down, it runs off the timer. You flick it to on, it runs 24 hours. All right, and the homeowners hate it when they end up getting, they make a phone call to you to say, hey, come on out, my pump, I had to wait for hot water this morning, something's wrong. And you come out and take a look at it and you notice, oh, we had a power outage for 3 hours last night. And now the timer is off and all you do is turn the clock on the dial and get it back up and running again. Then the last thing you do is put a bill on the table, obviously, right? Because you knew what to change. Homeowners don't like that bill. It's a very difficult bill to give, all right? And then they take a look at it the next time there's a power outage or daylight savings, and they just turn this thing on and make it run 24 hours a day, 7 days a week. You can do a combination of both. You can take the plug and add an aquastat to it. Best of both worlds. All right, you can do that easily. And now it really keeps the pump off and only runs when people need it or want it. All right, so again, it does have its defaults. But I do want to point out one little thing out there when it comes to thermostats and heating and cooling homes out there. We see lots of thermostats like this out there, right? All right, and why do we see this stat? Why do people love using these type of thermostats? I mean, heck, I've got 4 of them in my house. Yes, I have a 7-zone system, and I needed to test a whole bunch of them with new controls and things like that over the time. All right, so why do people like this thing? So Gene said right away, Wi-Fi. All right, that it's got Wi-Fi, that I can see it on my phone. I can go online and see what's going on. All right, unfortunately, that is actually low down the list. All right. Usually when they get installed in somebody's house, they're messing with it a lot the first 3 or 4 months they have it installed. After that, you're lucky if it's once a year. But now I'm going to ask everybody on here, do you have a programmable thermostat installed in your house? Not a Wi-Fi version, a standard programmable with all the buttons on it and a small little display, not programmed. I know I did for many years. And I would walk up to the thermostat and put it into setback every day. All right, it was the second floor thermostat for the air conditioning. And when my wife and I went downstairs for the day, we usually stayed down there for the rest of the day. And I raised the temperature to keep the air conditioning off. All right, more for energy savings than anything. What people like about these type of thermostats is that they will program themselves. They have motion sensors built in. They will also have geofencing, depending on where you are, to learn your patterns in the house. It's all about that energy efficiency. All right, that's why people really like these things. So what we did is created what we call the smart plug. And the smart plug is now going to take your circulator and learn when people use hot water in the house and only run the pumps for those time periods. It's an easy install. If you have one of our 006 E3 circulators that have the cord on it, you plug the smart plug into the wall, you plug the pump into that, and there's a temperature sensor that goes on the hot water supply side coming out of the water heater and will learn your patterns. If you can't wire this pump, put it down and step away. The hardest thing about it is finding an outlet near the water heater. That's the hardest thing you have, okay? You plug it in and it starts to learn what's going on in the house, all right? So here and this thing is always thirsty for knowledge, all right? It's always going to learn and adjust to your schedule. It's got a 7-day calendar built in, right? That 7-day calendar will also adjust itself and it's going to learn events. This is what it's not looking for actual temperature, it's looking for an event. And an event is a temperature rise, a duration at that temperature, and a temperature fall. And it says, all right, somebody used water at this time period, and I'm going to record it as an event. All right. And you can have as many events as a day, and you have 7 days built into it. Okay. So let's say it learned a shower at 7 a.m. in the morning, and it sees that duration of that shower being used in the morning. It doesn't know it's a shower, it just knows the water was being used, probably a shower at 7 a.m. So if that shower ran for a time period, let's say 15 minutes, what it's doing is actually going to give you a little bit more time of opportunity, because not everybody gets in the shower exactly at 7 a.m. All right. So what it's going to do is give you a little bit of window of opportunity now to jump in that shower. So a little bit before, a little bit after, based upon that duration that it was used at. Now, up here, this is the top here is representing my pump runtime or running. All right. It says, all right, I need to run for this amount of time. But during that time period, the circulator pulses, meaning 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off. The water is not going to cool down that fast. So let's say 7 a.m., you had that 15-minute shower. It's going to turn on at, say, 6:40 in the morning. So at 6:40, it's going to run for 5 minutes, prime the line, make sure it's available for you, and then shut off. Again, the water will not cool off that fast, so it's going to stay off for 10 minutes, and then bang, turns on again, runs for 5 minutes, okay? And then after that, say 8 o'clock in the morning or so, pump is off. We're just sitting there idle until it learns the next event. So on Monday and Tuesday, around 1 o'clock in the afternoon, maybe you're washing some clothes, the laundry room is running, okay? So you did a load of laundry, all right? It ran for a couple of minutes, shut off. Doesn't know what that event is. It just knew it as an event. And then in the evening, giving the kids baths, whatever, maybe a little bit longer of a runtime, because even though you're not running the water for, say, 2 hours straight, it's just that that event time kind of overlapped each other. So it says, all right, for 5 on, 10 off for those next 2 hours, really keeping the electrical consumption down low too, and obviously the velocity of the water. Now we're not looking at long extended run times. We're keeping them very short for only what you need. And then say 8 o'clock on, nobody uses the water. Nobody uses it, and it stays off until the next morning. Okay, so it's okay for the water pipes to get cool. Let's say on Wednesdays, nobody's home, so there's no laundry. So we just had a couple of events that ran, and that's it. So that's what the smart plug is doing and learning those events. Now, some other things that we have built in, now there might be people out there that don't have any schedule at home, like myself. All right, so my in-laws live with me, my wife is stay at home, the kids are in school, sports, things like that. There's water usage all the different times. There is no set schedule. The only person that has a schedule in my house is me, and half the time I'm away. So so what you can do on the plug, there's a little button at the bottom that you press and you put it into pulse mode. What that does is 5 on, 10 off all day, all night. All right, so it's not learning anything. It is just going to run 5 on, 10 off. So that's useful because this can handle up to 6 amps. So you can do some bigger pumps, and you could even run some commercial applications with this. All right, as long as you're not overamping the controller, you can run an apartment building, a hotel, things like that, because again, the water doesn't cool down that fast, and there's always a demand for hot water in larger applications like that. So that's what the pulse mode is being used for. So during COVID, all right, when everybody got locked down at home, heck, showers were taken at all different times of the day. So that's what happened. I ended up putting mine into that pulse mode, and I haven't changed it since. Now, the other thing that the smart plug is going to do for your system is, since it's always looking for hot water, it's always looking for that usage that you're going to see, temperature rise, duration, temperature fall. If it doesn't see anything for 36 hours, it will shut the pump off. All right, goes into a vacation mode. So therefore, we're not running the pump. No one's home. We went away. It's shut off. It's the weekend. Let's shut this thing down. All right, we're not going to run any longer. All right, and if it didn't learn anything, it's already going to shut itself down. Can we exclude late night from pulse mode? Unfortunately not, all right, because it doesn't know times of day that the smart plug does. All right, so, but interesting story. So I had the pulse mode in when I first put it in my house, all right, I knew it was running at nighttime because I put it in pulse mode. It was during COVID. And then I put another timer behind that so I can shut it down, say at midnight. The very next day, literally, Dave, the next day, my mother-in-law said to me, you know, I went to go take a shower at 1 a.m. and I had to wait for hot water. I couldn't believe it. It was literally the next day, all right, that they said that they wanted to use the water and hot. So yeah, I took off the extra timer behind it and just left it in the pulse mode. I did the calculations on the smart mode when it learned in my house. If it had if my house was normal, it was going to consume about $8 in electricity a year, because it was very short spurts, very low power consumption. That 7 watts of power that I was looking about. So I was looking about $8 in electrical. So Robbie's asking, will there be a development of adjusting the on-off time period in the pulse mode? And yes, it is. So later this year, you're going, another Takeo Tuesday that we're going to do is on our new Dash 5 controls. Wait a minute. Did I do that already? That was didn't I do the Dash 5 controls last week? I think I did, or 2 weeks ago. So take a look at last class that we did. And the new controls that have that built-in app, we do have Recirc built in, the smart plug that is adjustable there. In the future, we may. So at the moment, no, today, but I know it's a conversation that we want to be able to make this adjustable. So now what I do want to talk about real quick is, what about a tankless system? What about tankless Recirc that we have out there? All right, because I just went into tank design before. Let's talk about tankless, and we have what we call the Genie system. And the reason for that is that we have to look at some different designs. Tankless is looking for larger flow rates and dedicated return lines. All right, so you want to have a tankless unit that has at least a Recirc system that's going to give you at least a half a gallon a minute or more. Okay, so we do have another design out there, this product that we call the Genie, and this is designed for retrofit. What I showed before was running that dedicated return line, and you're not going to always be able to have that opportunity to run that dedicated return line. So now let's go underneath the sink at the furthest fixture, and we can put a circulator there, all right, with some controls behind it. Now this is showing a large circulator. We do have small ones. This one's our largest that we have out there. Will depend upon the size of water heater that you have, all right, and then you can go from there. And you can also use the app for that. So when the first question it said was, do you have a dedicated return line, you would select no, and therefore it would start looking at your Genie as you chose a tankless water heater. Now the Genie is a system that runs on command, meaning it's homeowner opportunity. They are the ones that are directly turning it on. The smart plug was an indirect, right? It learned your schedules. This one, the homeowner is going to turn it on, and it operates several different ways. It's going to operate with a push button or a motion sensor, and you can put multiples in the house. You put one pump, but you put multiple activations in there, motion sensors or button switches, in order to turn this thing on. Now what we're looking at, much different than the 006 E3, where that was going to be, so to speak, a slow and gentle flow. This one's going to be fast and furious. We are going to exceed the velocities, but for very, very, very short amount of time, 15 to 30 seconds. That's what the runtime of this pump is. It is to prime that pump quickly, or prime that line very quickly here. All right, so we could do dedicated return line with it, but mostly what it's used for is that retrofit where we put this underneath the sink. All right, and like I said, this is designed for your tankless units. All right, this is also designed for some, not all. You have to double check with your manufacturers on your heat pump water heaters. All right, so this can be used for the heat pump design. What I was talking about before was your tank style storage, not heat pump design, fuel fired or electric. All right, but your heat pump design, a little bit different of an animal. Check with the manufacturer on that. So if we take this circulator and put it underneath the sink for the standard design under the sink, we try to get the furthest fixture possible, as far enough away. And then we have several things that's going to keep this pump off. All right, so it's activated by motion sensor or that button switch. So your choice on any one of these fixtures, fixture groups having that sensor in there. And what it does is it looks at a temperature. All right, and we're looking at we're looking at a temperature rise. So there is also a temperature sensor on the Genie on the supply side here. And what we're going to do is use the cold water supply as the return to send it back to my water heater to get heated up. So instead of running a dedicated return line, we're going to cross over to the return line to pump the water back to the water heater and then deliver it back out again. All right. So that's what we're looking to do. All right. Question came in: can we work it with a flow detector, like a flow sensor? All right. At that point, it might be too late. All right, in order for the pump to turn on. All right. So the idea of this is when you walk into the bathroom, the motion sensor says, "Hey, I'm in here. Turn on." There's probably going to be a high percentage that you're going to use hot water. That's why you went in there in the first place. All right. Or you hit that button first and say, all right, let me hit that button, let's get the water primed up and then come back. But the flow sensor might be a little bit too much of a delay in there, Daniel. So we also want to make sure we have it available when you walk up to go wash your hands. So it kicks on, and what it's going to do is look at a temperature rise from when it turned on. And the default is an 8-degree rise. So if the water is cold in the hot water, it cooled down to room temperature, 70 degrees. And all we want to do is take this 70-degree water that's on the hot side and move 70-degree water on the cold side, which was already at room temperature as well. So we're not heating up the cold water side. All we're doing is taking the cold water that's in here and moving it over to the cold side to get sent back to the water heater and heated back up again, or going through your tankless. So you can use either one here. All right. And as soon as I get that 8-degree rise from when it turned on, so if the water was 70 room temperature, as soon as it sees 78 degrees right at the pump, because that means right behind it is going to be hot water available at the fixture. So depending on the length of run that you have here, it's anywhere between 15 and 45 seconds that this runs to charge the line to get that hot water there. All right, so yes, these are 006, 008, 0011 design circulators. So where I make the difference on which ones you choose, if I had a standard tank style water heater with a dedicated return line like this, all right, instead of doing the crossover design, then and tank style, then you could put the 006 in there. If you're back here doing the crossover, all right, tankless water heater, 2.5 bath house and smaller, I would use the 008 model. 2.5 bath house or higher, which means your water heater is getting bigger, has a higher pressure drop through the coil, I would use the 0011. All right, so those are the 3 models that we have for the Genie designs that we see there. All right, everybody, how we doing out there? Let's see, any questions? All right, exclude. Okay, I think I got everybody out there. If I ended, wow, about 3 minutes early. All right, so one, I do want to say thanks to everybody joining us for this class. The one thing I did not talk about was retrofit tank style with our hot link valve. That is for another class altogether. Make sure you come join us for another Takeo Tuesday class on the DHW out there. So this is your residential design. Don't forget the website for sizing it. We do also have it as an app that you can download. It is part of the Takeo suite, so it's not a dedicated app. You look at the Takeo suite of apps, and it'll be a web app that you can do onto your device, or it's right there on the website. You can also print out your reports and your designs as well, and you can create a whole spec sheet from the website in sizing your systems. Take a look at the website. Really, really useful. The one thing that I think that everybody overlooks when it comes to Recirc is smaller is better. All right, we need to go smaller. I get phone calls. If some of you out there know my previous life working for PEX manufacturers, I still get phone calls today. Hey man, do you guys ever have a bad batch? Because I got pipe splitting on me in Recirc. All right, it's 10 years, 15 years later, and there's holes showing up in PEX tubing, and I'd ask about the pump, what size pump is out there, and I've seen 009s put in for Recirc. 009 is a super high head. It's just screaming the water through there. All right. 006E3 set on low residential settings all day long. Is there a crossover model to use with a traditional tank heater? If you're looking at the Genie, it would be the 006. All right. So we have two different monikers at the end of the part number. We have the USK, which is under sink, and then we have the CT, which is for tank. All right. So thank you, KM. Greatly appreciate that question there. Now, in 23 hours time, you will receive an email from us saying, 1, thanks for joining us for Takeo Tuesday. 2, you will see your certificate of participation where you get your PDH as well. All right, so 23 hours time, you will see that email. If not, give me a shout. If anybody does need any of that information, if you can't find the handout pages that I showed you, those velocities, give me a shout on that, or just take a look on the Takeo Tuesday page or the webinar pages. Next week, we switch back over to commercial. All right, the commercial guys, Rich, Brett, and Tony, are going to be talking about pump curves and looking at Project Builder 2.0. All right, I was showing you that design page. You saw the Project Builder and Project Builder 2.0. That's the latest and greatest in sizing your commercial applications. So take a look at that next week. Come join us again. Again, sign up for every class. The reason why we do that is so we can get those PDHs out to you, that certificate of completion. And the other thing that I like about it, because I need it to remind me to show up. So it gives you that 24-hour reminder, and it also gives you that 1-hour reminder in showing up to your Takeo Tuesday webinars. So everybody, if there's no other questions out there, I'm going to say thank you. And for some of you residential guys and commercial as well, tomorrow night, all three of us, the trainers are here in Chicago. We will find some place to deliver Takeo After Dark. So Takeo After Dark, 7 p.m. Eastern time. All right. Again, hit that website if you want to register. Come hang out with us. Tomorrow night's class is going to be on zone valves versus zone circulators. Which one is better? That debate on how do you zone a hydronic system. And if you haven't been to a Takeo After Dark, we started off our first session with heat loss, and we're building our system as we go all the way through. So we got 9 classes to do. This is going to be part 5. All right, so part 5 is tomorrow night. I know I'm seeing a few names that are on here that I know have been joining us for Takeo After Darks as well. It should be a good time, most definitely, Gene. So, all right, everybody, thank you for joining us. Have a wonderful rest of your week. Enjoy.